Hi, I am SYAFIQ. I will explain about Green's theorem. Green's theorem gives a relationship between the line integral of a two-dimensional vector field over a closed path in the plane and the double integral over the region it encloses. In vector calculus, Green's theorem relates a line integral around a simple closed curve C to a double integral over the plane region D bounded by C. It is the two-dimensional special case of Stokes' theorem. First, if you have this line integral C, pxy dx plus qxy dy, so you can solve this by using double integration RdA. And then you have to differentiate your q respect to x minus with p respect to y. Then you need to find dA. So this is called Green's theorem. This is the explanation part. Let C be positively oriented, piecewise smooth, simple closed curve in the plane. What is the meaning of this sentence? So, positively oriented means counterclockwise. Piecewise smooth means composed of a finite number of smooth subcurves. Simple closed means start and end at the same point with no other self-intersection. Next is the application of Green's theorem. First, to solving two-dimensional flow integrals. Second, to transform a line integral into a double integral. Then, to transform a double integral into line integral. So, this gives us a more convenient way to calculate them for closed curve.
So this is an example of application, and this is the example of question.
Assalamualaikum dan hi. My name is AZRI bin ZULKIPLI. Today, I'm going to explain about the calculation for the Green theorem. So, let's go for the question number 1. Use Green theorem to evaluate 2x cubed y square dx plus x power of c y dy, where C is the triangle with vertices 0, 0, 5, 0 and 5, 3 with positive orientation. So for the step number 1, we will plot the graph using the coordinate given 0, 0, 5, 0 and 5, 3, and after that we will get the triangle. So for 5, 3 and 0, 0, we must calculate the gradient and y-intercept. We will use these 2 points 5, 3 and 0, 0, and we will get the gradient is equal to 3 over 5, and we will put it in the equation for the gradient. We will put it into the equation y equal to mx plus c. For the c, use these 2 points and we will get c equal to 0. After that, with the positive orientation, we will use the anti-clockwise formula for the Green theorem. For the step number 1, for the p, we know that the p for the equation p is given from the question. We will take p is equal to 2x cubed y square and q equal to x power of 6y. And after that, we must differentiate p and q. We differentiate delta q over delta x, and we get 6x power of 5y, and delta p over delta y equal to p x cubed y. For the step number 2, we will use the type 1 region by using this vertical line. So for the limit, we know that for dy equal to 0, and the out from the solid from the line and for the 2, and for the second limit is 3/5x, and for the x limit is 0 and 5. And we put the step number 1 into the equation green theorem. After that, we calculate the integration, and we get the answer is equal to 50859.38. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is NAJWAN AFIF bin AMIN NAZRIN, and I'm from group 21. Now I'm gonna explain and make a solution for step by step for the question based on green theorem. And I'm gonna make a solution for the question number 2. Question number 2 state that to evaluate integrate C 7y square plus exponent power of x square dx plus 2x plus y square dy, where the C is the circle x square plus y square equal to 4. From this equation, we know this equation form the circle graph, and the radius for this the circle graph is a radius equal to 2. To make a graph, we make a y-axis and x-axis for, and the radius for circle is 2, and we plot the 2 for the x and y, and we make a circle, and it form a circle. After that, from the equation, this equation, we can take out the p function and q function, and the p function, and we got a 7y square plus exponent x square, and q function is 2x plus y square. After that, after we take out a p function and q function, we make a differentiate of p and q. For the differentiate p, and we differentiate y. For function p, we got a 14y, and for the q function, we integrate from the q function, and we get a 2. For the step 2, we know the formula of double integrate r dq over ds minus dp minus dp over dy dA. From this formula, we know the differentiate of q function over x, and the differentiate for p function to y over y, and after that we substitute to this formula, and we got a double integrate r 2 minus 14y dA. From this we know this will form a polar form, and we change the dA to r dr d theta. For limit for r, we know the 0 until 2, and for the theta we know 0 until 2 pi, because of 2 pi, because the circle is a full circle. From this, we know the y, still in the y, we must make the form of r. We know the y is equal to y equal to r sine theta, and we put this to y, and we got this, and also we take out our 2, and we got a 1 minus 7 r sine theta, this, and we got the r minus 7 r square sine theta theta. Now we integrate the r like this, and we got the r square over 2 minus 7 r power of 3 sine theta over 3. After that, after we integrate, we put the value of integrate r 2 and 0. After we put, we got 2 minus 56 sine theta over 3. After that, we integrate for theta. We got 2 theta plus 50 cos theta over 3. This is from a task because we got, after we integrate the sign, we got a minus cos, and minus to minus, we got a positive. After we integrate the theta, we put a value of 0 until 2 pi. This, we put the value for this question. And we know the cos 2 pi is equal to 1 and cos 0 is to 1. Now we can, the 56 over 3 will pass to we minus 56 over 3 and it's be gone. And after that, we got 4 pi because 2 times 2 pi times 2. After that, for the last answer, we got 8 pi. Okay, that's all for me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FAIS bin Muhammad YUSOF. I'm from section 2. I will explain how to solve the question 3. The question is use Green theorem to evaluate this equation where C is positively oriented closed boundary and closed by parabola y equal to x square and x equal to y square. We go to the first step, which is we need to identify pxy and qxy. We took from this equation to get a pxy and this equation to get a qxy equation. Then we differentiate dp over dy. We got 6y. Then we differentiate dq over dx. We got 12x squared. Then we go to the next step, which is we need to find the intersection point to sketch the graph later. So we need to find the value of point x and point y. First we find the value of point x. We got 0 and 1. Then we substitute the value of x into y equation. We got 0 and 1. Then we sketch the graph. Use this equation y equal to x square and this equation x equal to y square. We got this shape of graph. This intersection point 1 1. This the region that we will use to find the double integral later. Then we go to the next step, which is we need to find the double integral. We use the formula of double integral dq over dx minus dp over dy dA to solve this question, we need to use type 1 region, which is we need to sketch the line vertical at here. Then we will get the value of limit dy and dx. For dy, set x and x square. For dx, 1 and 0. So we will do a double integral of 12x square minus 6y dy dx. We go to the next step. Okay, we integrate 12x square minus 6y dy dx. First we integrate to dy, then we got the equation 12x square y minus 3y square dx. Then we substitute the value of limits dy into this equation, and we can see this equation after we substitute. Then we get this equation, which is 12x power of 5 over 2 minus 3x minus 9x power of 4 dx. Then we integrate to dx this equation. We got 24 over 7 x power of 7 over 2 minus 3 over 2 x square minus 9 over 5 x power of 5. Then we substitute the value of limits dx into this equation. Then finally we will get the final answer, which is 9 over 70. So from this slide into this slide, we get the final answer 9 over 70. So hopefully you guys can understand the step how to solve this equation. So see you next. Thank you.